Hey everybody, since we did not go over the exam in the meeting today, I told the students that attended that I was going to create a video, and here it is, on the key for exam number 3 that we just got finished taking last week. So real briefly, what we'll do is we'll draw on this thing, and I'll actually upload the scribble for you so that you can look at it as well. So the first one, you're looking for the critical numbers, so that means what you need is you need to take the derivative of this guy, and when you do that you get 4x cubed minus 48x. Basically, when you factor, you've got 4x and then you've got x squared minus 12, so the critical numbers are 0 and plus and minus square root of 12. So finally you might say 0 plus or minus 2 radical 3. Okay. Number 2 was a little bit different. We did it in different ways. What I did for this guy is I did it by the product rule. So I got a 2/3 x to the negative 1/3 power, and then times 5 minus x, and then minus, when you derive this guy, all you get is a minus, so you get x to the 2/3 power, and then you set the thing equal to 0. When you set it equal to 0, I got like 5 minus x over 3x to the 1/3 power, okay, is equal to x to the 2/3 power. And when I multiply that over, you get 2, and then 5 minus x is equal to 3x. So that gives you the answer 10 that a number of people got. But don't forget, this guy down here also, so x is equal to 0 and 10. Those are the critical numbers, because at 0 it's actually not defined. And that is a critical number. Okay. All right, so we're looking for increase and decrease. What I was looking for on this one was the first derivative test, where you're marking off 0. You got negative 2 root 3 and 2 root 3. And what I found when I did this was I tested the intervals, and they do something like this, because it's negative, it's positive, it's negative, it's positive. So right away we have increase, decrease, and I'll let you fill in the blank for that, but that's what you're supposed to do. Basically, you start going like minus infinity to minus 2 radical 3, and so on. Okay, so you're just looking right here. For the first derivative test, what you have, you're staring at, there's a min, there's a max, and there's a min. So you tell the world, that's what I've got. Where's that problem? Number 4. We have a max of f of 0 is equal to 0. And in a min, we have f of plus and minus radical 12, if you will, or 2 root 3 is equal to negative 144. So doing some major work here. For concavity, you take the second derivative and you get f double prime is equal to 12x squared minus 48, which leads to a couple of potential numbers, that is plus and minus 2. Yeah, when you square root, it's plus and minus, so you mark those guys off, and you test the sign of the second derivative, and it's positive, it's negative, it's positive, so it's concave up, then it's down, then it's up again. So that's what you do. You go concave up, okay, minus infinity to minus 2, and I'll say etc. again, because you know the drill. The inflection points are found to be, yes we do, we have, it changes concavity here and here. It switches from plus, minus, minus, plus. So that's going to be, I forget what the number was, but they occur at when x is equal to plus and minus 2. Okay, I really didn't grade whether you put the function value in that one. Okay, to the next page then, absolute max min. We need to talk a little bit about number 7. When you take the derivative, you get 3x squared plus 3x minus 18. You set it equal to 0. What you end up with are two numbers after factoring, however you want to do it, and I'm fine. Oh, there they are. It's negative 3 and 2. Now here's the thing, folks. This interval is 0 to 4. So that means from 0 to 4, the only one that fits in there is 2, because negative 3 is outside the interval. So you really just want to check out 0, 2, and 4 for max and min, and what we found is, okay, I found that I got a 4 here, negative 18, and then I think 20. So the absolute max is f of 4, is 20, and the min is f of 2 is negative 18. Okay, moving on. All right, this one's tougher because of the derivative, but you guys all know where the vertical and horizontal asymptotes are. X is plus minus 2, and y is equal to, since the powers match, the ratio of the coefficients is 3. Good job. Okay. Increasing, decreasing. I'm picky on looking at the work. When you find g prime, it's the quotient rule, and I'll just cut to the chase on number 9 and tell you that I ended up with minus 24x over this guy squared, x squared minus 4 quantity squared. That's actually an easy one to test. What I did is I wrote down, hey man, I've got critical numbers of, let's see, well, the critical numbers are, from the top, the critical number is 0. That's when it's 0. But also, plus minus 2, it's not, that's where the asymptotes are. So I marked those off, minus 2, 2, and 0. And then I went ahead and tested it and went positive, positive, negative, negative when I tested. Okay. So the asymptotes cannot be maxes or mins. These are just the asymptotes here. But look at, we have a max right there. We have that's for the second question. But for increase, what I did was, and you don't have to, but I did this. I went minus infinity, minus 2, it's an asymptote, and then minus 2 to 0. Okay. And then etc. there too. And any relative max mins? Yeah, there's a max, a local max, of f of 0 turns out to be 0, okay? And then when you sketch this guy, it actually has the horizontal asymptote of 3 and a vertical asymptotes of minus 2 and 2. So you mark those guys off. And then you go ahead. I think we have enough information. Since he's a max, this guy is just going to be drooping down like that. And since this is decreasing and no more zeros, there you go. And also increasing here. That's the only choice. And that's what we have for number 11. Okay, going to the last 2 pages. We're trying to find, the mean value theorem. Very fast way of doing this is just go f prime is negative 2 sine x. And then you set it equal to the slope of the secant. So it's going to be cosine of pi over 2 minus, 2 cosine of pi over 2 minus 2 cosine of 0 all over pi over 2 minus 0. So you end up with minus 2 sine x. And when you clean that all up, let's see what I got. You end up with, where am I? 2 over pi. No. A negative 4 over pi. So sine x is positive 2 over pi. So the answer is C, if you will, replacing, is sine inverse of 2 over pi, whatever that is. And if you compute it, actually it's approximately 0.69, okay, which fits snugly into that interval. Okay, this one is very popular, this word problem number 13. So to set that up, you just take the equation of a semicircle of radius 4, and you realize that you can say x squared plus y squared is equal to 16, or y itself is the square root of 16 minus x squared. So when you draw your rectangle in here, however you want to, and you call that x, well, this y is that side. So the area of this guy is 2x times y, right? Another x is over here. So you end up with 2x square root 16 minus x squared. Well, then you do your magic. What is a prime equal to? It's a little bit sticky. You end up with like, let's see. With the product rule, you go 2 and then radical 16 minus x squared. And then you end up with plus 2x. But then up here, you've got a minus 2x, 2 square root 16 minus x squared. Set it equal to 0. And that's fun in algebra to solve that. And what you end up with is finally x is 2 radical 2. So when you plug that number in for, where is it? Where are you, y? When you plug that number in for y, you also get 2 radical 2. But the dimensions are the length, which is double x. So it's going to be a 4 radical 2 by 2 radical 2. That would give you the greatest area right there. And the open top, I thought you guys would sleepwalk your way through it because we did one or two of these guys. But anyway, what you're doing is the volume is said to be 108. And of course, the volume, if it's a square base, is x, and h. So the volume is equal to x squared h, which allows us to say h is 108 over x squared. And we're trying to minimize the surface area. Well, the surface area's got a bottom, which is x squared, and it's got 4 sides. It's an open top, so it's just no top, but 4 sides. So it's 4x times h, okay? But then when you replace h, you end up with a is equal to x squared plus 4x times 108 over x squared. So now you're off to the races finding a prime, and eventually, when you set it equal to 0, you end up with x is equal to 6. Well, then when you plug that in for h ends up being, what, 3, I think. So you get, finally you get 6 by 6 by 3 inches is the answer to number 14. Okay, so the last page, we're going L'Hopital twice. The first time you get lim. How would you know that? What happens is when you take the first derivative, you've got, where are you? Sine 2x over, sine x over 2x. But that still leads to 0 over 0, so you do L'Hopital again. And you get lim. X goes to 0. This time you get cosine of x over 2, and this time you get 1 over 2, and lo and behold, that's the answer. For this other guy, people knew that the answer was e, but you gotta show it to me. So I showed you this technique of it's equal to lim as x approaches infinity e to the natural log of 1 plus 1 over x to the x. And so this x here can drop down in front of the natural log. And you end up with lim. This is kind of a weird way to do it, leaving the e in there. Books don't do that generally, but I like to. So you're really looking at, let's see, you've got natural log of 1 plus 1 over x over 1 over x. And lo and behold, when you take that limit, you have to do L'Hopital on it once, and you end up with e to the 1. So the answer to this is e. Okay, the limit of the power is 1. Okay. Newton's method, okay, fine. What I chose was, you can use a calculator and say, oh, it's, but I was doing this. 2 to the 4th is like 16. 3 to the 4th is like 81. He's a lot closer to 30 than 81 is. So I chose x1 is equal to 2, then x2 is equal to 2 minus, and how does it go again? Which one's on top is always my problem. I don't want to keep reinventing the thing. Number 17, where are you? And so it's going to be basically the original function on top of the derivative. Okay, so that's what I did. You guys know it's going to be, the original function would be like 2 to the 4th minus 30 over 4 times 2 to the 3rd, and you get a number. And like I said, you iterate it on your calculator until you get this. And this was a mistake here. So if you followed that, I gave you full credit. The instructions, I should have gotten rid of that guy. In fact, I will right after this conversation. But you end up with, you get 2.340, 347, I think, and 319. And that's accurate to that point anyway. Okay, the antiderivatives is really quick. So you get like equals 4/3. Everyone almost got this one right, which is wonderful. 6x squared. You guys are ready for the next adventure, plus c. And this one is natural log of x minus 3e to the x again, and then plus c. And finally, the last one, you're integrating this. So f of x, upon anti-deriving, is going to be, what did we get? 5/3 x squared cubed? No, 5/3 x cubed. Okay, and plus cosine x, and then plus c. But when you plug 0 into this thing, this is 0 plus cosine of 0, that's 1 plus c, and I want it to be 3. So you get c is equal to 2, and you rewrite your answer, and you go, my answer is f of x is 5/3 x cubed plus cosine of x plus 2. Yay! So that's the test. That's what we took. So use this to kind of look at your work and correct it. And I'll see you at the next video. Okay. See ya.